Hello student, how are you? I am Arun Sir, qualification Bachelor of Engineering from Jadavpur University. Welcome to my channel Tuition Expert. Today in this class, I will teach you relative velocity part 2. In this class, I will teach you the river boat problem. Now let's start about the river boat problem. Suppose this is a river, the velocity of river is here, right here. Here equal to velocity of river. W is the width of the river. Width of river. VDR, actually this is velocity of boat with respect to river, and VB also it is called velocity of boat in still water, because VBR equal to VB minus VR. So if VR equal to 0, that is still water, then it becomes velocity of boat. VBR means VB minus VR. So if VR equal to 0, that is in still water, then it become VB. So it is called velocity of boat in still water also, and VB equal to actual velocity of boat with respect to ground. Now we can write VB equal to VBR plus VR, because VB minus VR, so this becomes VB minus VR plus VR. So we can write this plus this. Now if a man want to cross the river, then two conditions is satisfied. One is shortest time and one is shortest path. Now we discuss the general condition, then after that we discuss the special condition. Suppose a man, this is VBR, that is velocity of boat with respect to river, and this is VR. So we take this is X, this is Y. Now if this angle from the vertical, suppose this is the vertical line, and if this angle is theta, we take this angle is theta, then component of VBR along this is VBR cos theta, and along this is VBR sin theta. So what is Vx? Vx equal to VR along x direction. So Vx equal to VR minus VBR sin theta. This is Vx. Vx equal to this minus this minus this, and only one component in the y direction, that is VBR cos theta. So two things we get, Vx and Vy. Now to cross the river, we need velocity of y along y direction. So suppose this is with W. What is the time taken to cross the river? The time taken to cross the river will be W by Vy, because to cross the river the boat should move along this direction. So W by Vy, W is width of the river, Vy equal to cos theta. And if along x direction, what is the, this is called drift. Drift means, suppose the boat boat reaches at this point. So from this to this is the drift. This is the drift. Drift is denoted by x. X equal to velocity along x direction into time taken. Time taken to cross the river is this. So this is called drift. Drift dx equal to this into t. So this is the general expression of drift, and this is the time taken. Now special condition arises. Two case arises. First case, to cross the river at minimum interval of time. So time should be minimum. T equal to cos theta. So time, if the time is minimum, then cos theta should be maximum. Cos theta equal to 1, that is theta equal to 0 degree. So cos theta equal to 1, T minimum. Minimum value is VBR when theta equal to 0. Theta equal to 0 means we take the theta along from this vertical direction. So if this is VBR and we take this is theta, so if the boat initially move along this direction, that is theta equal to 0. Theta equal to 0 means, the boat should move along this direction. If the boat moves along this direction initially, then the time will be minimum. Time taken to cross the river will be minimum. For that case, drift will be x equal to this. And sin theta, if theta equal to 0 degree, sin is 0. So if theta equal to 0, then here sin theta, sin 0 0, that is drift will be VR W by VBR. This is the drift along this direction, and velocity of river along this direction. So the boat reaches at that point. Velocity of VR equal to this. So the boat reaches at that point to travel, to cross the minimum at minimum interval of time. The boat reaches at that point. Crossing of river at shortest path. The boat starts from that point A, and he want to cross directly just opposite of A, that is at B. This will be the shortest path. This will be the shortest path. So the boat steers at an angle theta. This this is VR, this is VPR. So result velocity this. This plus this equal to this VP. This will be the velocity of boat. So the boat cross at shortest path, that is along this path. Now we have to calculate the theta. So at which angle the boat steer such that he cross the river along the path AB. So from the triangle this tan theta equal to perpendicular by base or if this given and this given, we can get sin theta equal to VR by VBR. Sin theta equal to VR by VBR. This by this. So we get that result from this relation. If this is given, then we can get theta. So now this is the direction of VR. If we get theta, then you need to express the direction with respect to river. So this angle you have to mention this angle. This angle will be 90 plus theta. So direction of VBR should be 90 plus theta with direction of flow of river. This is 90 plus theta. If we get theta, then we can write the direction of velocity of VBR. Minimum path traveled by boatman while he crosses the river. The topic is what is the minimum path traveled by boatman while he crosses the river. Okay. Now suppose this is river and W is width of the river. The boatman starts from this point. We want to cross the river. VBR, VR. Now here VR equal to velocity of river. VR equal to velocity of water of the river. So VBR equal to velocity of boatman with respect to river. It is called velocity of boatman. Velocity of boatman in still water. And VB, this is velocity of boatman with respect to ground. This is called actual velocity of boatman. This is called actual velocity of boatman. Now suppose the boatman steers at an angle theta with vertical. That is, this is the shortest path and this angle be theta. That is, the boatman steers at an angle theta from the vertical line. So the component of VBR along this and this VBR cos theta, and this component is VBR sin theta. Okay. Now take, this is x direction, this is y direction. So what is velocity along x-axis, net velocity along x-axis, Vr minus Vbr sin theta, and what is Vy? Vy is this cos theta. Now from this, what is the time taken to cross the river? So if the distance is w, then we can calculate the time, which is distance by velocity. Distance we take along this direction, so velocity we have to take the velocity along this direction. So that velocity is vbr cos theta. We take the distance along this path, so we have to take the velocity along this direction. So time taken equal to distance by velocity. This is time taken. Now two cases arise here to find the shortest distance. Here we take two cases. For minimum path traveled, case 1, case 1, when x is 0, depth is 0, that is the boatman starts from this point and directly he reach at this point, that is this is the shortest path. So for that, x equal to 0, if the boatman starts from here and reach at that point b, then x will be 0. So for that the condition is depth x, we know x equal to distance equal to velocity into time. Velocity is vr minus vbr sin theta into time. Time is w by, this is velocity into time. So if x equal to 0, so this equal to sin theta, and sin theta equal to sin theta equal to this. Now as sin theta less than 1, so vr less than vbr. So for this case, when x equal to 0, then angle is given by this sin theta equal to this, and vr less than vr. This is the condition when x equal to 0. Vr less than vr, sin theta will be this. That is the condition for x equal to 0. Now for that condition, the path is shortest. That is shortest path traveled is w. Now if case 2, if vr greater than vbr, suppose this is vr and this is vbr, this angle is, we take theta, then if we draw the parallelogram, then what is the resultant of this and this? This resultant will be this direction. So the boatman reaches at that point. So now the path traveled by the boatman is this. So this is x and this is w. So what is the path here traveled? S equal to root over w square plus x square. Now w is constant. W is constant. W means width of the river. W is constant. So S minimum equal to, x is variable. x is variable, velocity into time, velocity along x direction, this is x and this is y. So velocity vr minus vbr sin theta, this is velocity into time is this, time is this, so this is x, velocity into time. Now this is, so x is variable, variable for what? Variable for angle theta. So at which angle the boatman steers such that x is minimum. For that we have to apply the calculus method. We know dx by d theta, theta is variable, dx by d theta equal to 0 for x minimum. In calculus we know dx by d, x is the function of theta, that is x variable and variable is theta. So we have to derivative with respect to theta, dx by d theta is 0 for x minimum. Now what is the derivative of this? So dx by d theta, here w is constant. Now this u by b, take, use the formula u by b, use this formula. So this is cos square theta. Now derivative of this is minus vbr cos theta, derivative of u into v constant, that is minus this constant into derivative of this. Derivative of this is vbr cos theta derivative sin theta minus sin theta. Okay, so this is the derivative. Now this equal to 0, this equal to 0. So what comes? This becomes 0. That we take common vbr, if we take common vbr square, zero, we take common vbr, this is a 1. So sin theta equal to vbr. So if the boatman steers at an angle theta with vertical, then the path will be minimum, and here also condition is satisfied because we take vr greater than vbr and this angle, so sin theta less than 1. Now the value of sin theta will be this. Now what is the minimum path? Minimum path is, what is the minimum path? So s minimum equal to root over w square plus x minimum. X minimum is x minimum equal to velocity into time. So this is vr minus vr sin theta, time equal to w by vbr cos theta. So this is square. Now what comes here? W square plus, if we take if we put sin theta equal to this at here, this, now cos square theta, we know cos square theta equal to 1 minus sin square theta, sin theta equal sin square equal to this, put here Therefore S minimum equal to, if we calculate this, the result is this what will be the value of S minimum? S minimum equal to W square plus, if we calculate this becomes V r square minus VB r square by V r square, then this is whole square, W square divided by VB r square into V r square minus VB r square by V r square. So cancel this and this, cancel this and this, one term this and this. So the result becomes plus, if we take common W square, 1 plus this by this minus 1, this cancel. So result is W VR by VBR. This is the result, S minimum, and the angle is sine inverse this. So if the boatman steers at this angle, the path will be minimum and the minimum path will be this. So that is the condition. So result is S minimum equal to this. Result is this, S minimum, and the angle at which the boatman steers is this. So this is the result. Now this is the end of the class of relative velocity. Okay, thank you.